Well, good morning, ladies and gentlemen. It's actually 9 a.m, so we've got a very full program this morning, so I thought we might try and start at 9 a.m. Firstly, I must thank you all for being able to get here. Such a good turnout at this time of the day, so we really appreciate that, looking at the weather outside. And hopefully we can give you a good and full program this morning. My name's Greg Scott. I'm in the UN GGIM Secretariat in New York in the United Nations Statistics Division, and I'm going to moderate your session this morning. What we have today with a title on geostatistics, and very much this is a topic around integration of geospatial and statistical information, and we've got five very good case studies and knowledgeable experts in this field for us this morning, so we are actually very privileged. What I will do in terms of running the program this morning is that we have a 90-minute session, as you know, so we need to get you out of here at 10:30. We have 5 speakers. We will allow 15 minutes each for speakers, and then we will have a question and answer session after that. So on one hand, I'm asking my speakers to be punctual, and at the same time, if you can hold your questions till the end when we open up to the floor. So without further ado, I'll start off, and I would like to firstly introduce Miss Marie Haldorson from Statistics Sweden. Marie is the director of at Statistics Sweden in the Regions and Environment Department. She's a member of the Swedish Spatial Data Advisory Board and is also currently involved in UN GGIM work in Europe and the coordination of GeoStat2 project. And her title for today is Getting Statistics and Geography Together. And so welcome, Marie, and you have the floor. Thank you.
Thank you, Greg. Thanks for your kind introduction. I will be talking about a topic that's actually very generic and supposedly the topic for the whole session. So as you can see, I will be a bit more specific talking about an ongoing project that is called GeoStat2. Of course, when talking about projects, there are numbers and numbers of them. So why is the GeoStat2 project such an important project, you might ask? And this is an answer to that why. To foster a better integration of statistics and geospatial information in order for the statistical community to provide more qualified descriptions and analysis of society and environment. And often when we talk about these things, how we from the statistical community are very keen on interacting with the mapping community, this is what it's all about. We want to integrate, we want to use geospatial information in order to create better statistics and, of course, for the users to have good descriptions of the society. So this is also another picture of why we are doing this. Because by combining geography and statistics or geospatial and statistical information, you can do lots of important analysis, of course. You can see how flooding might affect the neighborhood. You might look at time distance to the closest primary school, like this example shows from Portugal. You can count the access to public transport. You can describe green infrastructure within localities, and you can do land accounts for biodiversity. So you can create lots and lots of things. It's not just about putting data up on a map, it's something much more. And just to give you some words on the situation in Europe. Of course, GeoStat2 doesn't work it doesn't start from the beginning. Lots of work has already been done, and there are also various initiatives going on. So I just would like to mention a few of them. One very important player in Europe is the European Forum for Geography and Statistics. It's an expert network that has been driving the development of the integration between geography and statistics. And also we have the GISCO group. It's a group that meets at Eurostat once a year, consisting of both mapping and statistical agencies. We have the GeoStat 1, the predecessor of GeoStat 2, of course, with the main aim to create a grid, a kilometer grid with population for Europe. We have the UNGIM, where Greg is very active, and we have in Europe now created a working group dealing with integration, and there I can see a big benefit to use the results from GeoStat 2. Of course, we have the Inspire. We will make use of Inspire within the project. We also will promote the use of administrative sources, because that's something that is in place in many countries in Europe, not all, but many countries, and then we can show what a great potential it is to have administrative sources and not just be depending on censuses, but to have this yearly updates and being able to connect to the geography. And of course, there's the census coming up. So this will be an important input also for the census project, to see how the countries in Europe can be able to link statistics and geography in order to create grid statistics mainly. So what are the contents? Well, there are 4 points, 4 work packages in the GeoStat 2. The first one, and perhaps the most important one, is what I've already described. It's a point-based framework that we will suggest in the project. We also want to consolidate existing knowledge. You know, the area of spatial statistics is still quite a new area for the statistical institutes. It's not so formalized. It doesn't come with lots of guidelines and recommendations and so on an overarching level. So this is something that we will try to do within this project, to extend the knowledge base. And one important aspect is also to exchange knowledge. I'll come back to that, and also to support this Forum for Geography and Statistics in Europe, this network of experts. We will be going on for 2 years. We started off in February, and we will have a final report ready for the GISCO meeting in March 2017. So just to go through the various work packages, the point-based framework is, I would like to stress that it's a model for a national geospatial reference framework, because we think that you must start on a national level in order to then perhaps move to the European level, but you need to know what you are doing on a national level first. So we will start by doing an assessment on the current situation, and then of course analyze that, and also discuss our findings with the mapping community, because this is very much a joint effort. We need to interact, and in doing so we will look for best practices, of course. That's always a good way to start, and then we make our final proposal. And just to give you an idea what this could look like, this is a proposal still at a very early stage, how you can look at such a framework or a model where we use this process model that now is very common in the statistical within the statistical institutes and try to add on the geospatial dimension. And Rina, who has done this, is actually going to give a talk later, so I was very happy that she was able to give me this, as Rina is a part of the project, in order just, to give you an impression what this could look like. Then we have exchanging knowledge and creating an information base. So there is, we will look into the possibility of creating some kind of wiki solution. We also have to maintain the current website of the EFGS. So, of course, the wiki and the website of the EFGS are very strongly connected. At the current stage, we are working in this direction, that perhaps it is the EFGS website that will contain also sort of spatial statistics explained. That's the wiki part. And we are working in the direction to have both one more general, easy to understand approach, and also one more for professionals, for advanced users. Then last but not least, of course, there's the networking. And I don't know if you are familiar with that, but the EFGS arranges conferences every year. So the next conference will be in November in Vienna. So I, of course, would like to invite you all to come to Vienna and to attend this conference, and to where you can learn about the latest from, well, of course, GeoStat 2, but also a number of other initiatives, good examples. It's really the place to be if you want to share good practice with your colleagues at an expert level. So I can strongly recommend you to come there. And, well, who are the people doing this? Sweden, and I am a coordinator of this, but I, of course, have a very good team who works with this at Statistics Sweden. And then we have Finland, Rina is here today. We have Norway, Poland, France, Austria, and Portugal. And, of course, then we interact with the EFGS steering committee as well, as a reference group, and, to keep us on the right track, and so on. And the financer of it all is Eurostat, so we are also having Eurostat in the project. When you do this kind of thing, you, of course, want to make it known, so I'm very happy that you are a lot of people here to know about this now. And you can follow what is happening on the EFGS website. There will also be interaction with the ongoing work in UNGI in Europe. We have the conferences and we have the GISCO meetings. So to conclude, I invite you all to participate and to provide us with good examples, give us your ideas, provide papers perhaps for the coming EFGS conference, and as we will be sending out a questionnaire, perhaps you will be the person answering that, and we will be very happy if you provide us with your current situation in your country. So, thank you.
Thank you, Marie. Much appreciated, and sets the benchmark for keeping our other presenters on time as well. So thank you. Marie gave a very good introduction there in terms of why we need this integration of statistical and geospatial information, and particularly around generating better statistics, better analytics, and also visualization. And she mentioned this idea of point-based model in statistics as well. And so in that regard, I'd like to now introduce our next speaker, Miroslaw Migacz, who's the Chief GIS Specialist in the Central Statistical Office of Poland. Now, Miroslaw is the Chief GIS Specialist, but he's also one of these guys that's also a geeky guy in terms of programming and development, a person after my own heart, I might add. And he's also not only been working actively in Poland, but also in the creation of spatial address databases used in nationwide censuses to produce point-based statistics. So what we're going to see with the topic from paper maps to point-based statistics, a further continuation of what Marie briefly introduced. So thank you very much, sir, and you have the floor.
Thank you for the introduction. Along with Marie here in the GeoStat2 project, we are currently trying to develop guidelines for other countries to produce point-based statistics, and today I'm going to tell you a story of how our office went from paper maps to point-based statistics. First, a few words on how we built our GIS, then how we used the census process to improve the GIS we have created, then what this GIS has done to improve the census process, and in the end a few words about our project, the GeoStatistics portal, which we use to disseminate census results, and not only. This is what GIS looked like in 2009 in Polish official statistics. Everything was kept solely on paper maps. The first decision we had to make is what data do we want to collect in digital form. Those were statistical address points. We needed locations of address points for dwelling locations, and the boundaries of our statistical division of the country, statistical regions and census enumeration areas. Those are statistical units that are below the allowed 2 level. We collected a lot of reference materials, the orthophoto map, cadastral data, boundaries of the statistical administrative division of the country, a few secondary reference materials such as land parcel identification system, road and street network, geographical names, and the topographic database. We executed a pilot project. We chosen 4 municipalities to take part in a trial agricultural census before the actual census in 2010. We acquired statistical division boundaries and address points. This process allowed us to assess the quality of reference materials we used for this project, and most importantly, assess time that we need for a nationwide operation to acquire statistical address points for the whole of the country. This is how the project looked like. First, we scanned and calibrated our statistical maps. Then, based on these maps, we digitized boundaries of statistical division, regions and census areas. We took the cadastral data we got at the time. We extracted automatically address points that were connected to buildings or parcels. And of course, not all address data was available in the cadastral data at the time, so the rest was up to us to acquire manually based on the paper maps that we possess in our office. This is the work schedule for the nationwide address point acquisition. We started in 2009. Basically, the whole year was spent on collecting reference materials from various authorities. In January 2010, we started processing the reference materials and gradually sending them to our regional offices where our GIS operators started acquiring address points. The address point acquisition process took half a year, and the database is since then continuously updated. To summarize the building of the GIS in Polish official statistics, in 6 months' time, 210 GIS operators in our 63 regional offices acquired almost 6 million address points, which we then used for the census. Before the census process, we had an opportunity to update our database. In July 2010, we organized a 3-week action of address point update in municipalities. We have set up an internet map service. Municipality authorities had been obliged to check if the position of address points that are connected somehow to agricultural holdings are correct. If there was a problem, they indicate modification on printouts, send them to our regional offices, and they manually had to enter them to our databases. Just before the census, we had a 3-week action of visual survey by enumerators. All enumerators checked the positions of address points in the field. This is the web service we have prepared for municipalities before the census in 2010. The action before the population housing census was quite similar, with one big difference. We also set up an internet map service, but this time we allowed online editing, so there was no need for municipal authorities to print the maps and send them to us. The results were imported automatically to our databases. And as well, as with the agricultural census, enumerators check the position of all address points that we have collected in a 3-week action before the census process. This is a view of our web service for municipalities before the population census. To summarize this part, to date we possess the only set of address points in Poland that is complete and has been verified in the field by our enumerators, and it has been created and is still maintained within forces of official statistics. Now a few words on how we used our built and updated GIS in the census process. Both main applications of the census, which were the application for dispatchers and mobile application for enumerators, relied strongly on GIS. Dispatchers had at their hands a map module of the dispatcher application, which supported them in enumerator supervision. They could assign tasks using a map. The tasks were address points during the visual survey and interviews in the census process itself. They could monitor the trail of each enumerator, and they could offer enumerator support. Other thing that the dispatchers were obliged to do is to monitor completeness of the census, which was also based on a map module. This is a table view of a dispatcher application. And this is an example of a trail of one of the enumerators in the field on one day of the census. Enumerators were equipped with PDAs, on which there was a mobile app connected to our central network via a VPN network. The application contained a map module relying on GPS or thermometry cadastral data, and all tasks that were assigned to enumerators were also visible on a map on this PDA. The application also contained a communication module allowing enumerators to phone dispatchers, message them, or trigger an alarm procedure if there was a need for that, and the census module, which held tasks and questionnaires. A few screenshots of the mobile application and the map module of this mobile application. So after all this work and data collection, we finally entered the stage of data dissemination. That's why we created the GeoStatistics portal. This is the address. The project was being developed since 2011, but has been launched in July 2013. What's it for? First of all, we wanted to geo-visualize our statistical data, mostly census results. We also wanted to publish spatial data that we produce, and those are boundaries of our statistical division. And we are obliged by Inspire to provide network services, so this is also a part of our portal. When it comes to data sources, the primary data sources in the beginning were the results of the agricultural and population housing census. We also connected the local data bank. This is a data bank with statistical data of a broad scope that are mostly available down to municipality level. For now, we have data for years 2009-2014, actually. We also take part in Eurostat grants, the various stages of the GeoStat project, and also the actions called Merging Statistics and Geospatial Information. Those also result in geostatistical products, and we also publish them in the portal. We have various cartography presentation methods, the basic choroplete maps, and all kinds of diagram maps, which I will show in detail further on. An example of a simple choropleth map and our diagram maps. We have a simple proportionally scaled circle diagram map, proportionally scaled bar diagram map, a structural circle diagram map, which also can be proportionally scaled. Structural diagram maps can also be created using bar charts, and those can be scaled as well. For users who want to present 2, 3, or 4 completely different phenomena on one map, we also have a tool for that. This is called the complex diagram map, and it can present 2, 3, or 4 completely different phenomena. And as I said, recently we published also statistical grid data from the Eurostat project. For now we publish total population in a 1 kilometer grid, population classifications by sex and 3 age groups, femininity ratio, and more presentations are going to come in the following months. Inspire obliges us to provide data for 2 Annex 3 spatial data themes. Those are statistical units and population distribution. We have a discovery service running, view services running for both of the teams, and download services running for both of these teams with data compliant to the data specifications published in GML. All datasets and services are described by Inspire compliant metadata. The datasets in detail, we provide for statistical units our statistical regions and census enumeration areas, also the territorial division units for statistical purposes. We call it NTS in Poland. They basically comprise the 3 NUTS regions and 2 local administrative units. For population distribution, we disseminate total population in statistical regions and census enumeration areas from the census, and total population classification in those NTS units described just a second ago. All datasets are available publicly and free of charge. Talking about Inspire, I cannot fail to mention the Inspire thematic clusters. I have the pleasure and responsibility to facilitate the thematic cluster for statistical units, population distribution, and human health and safety. I would like to warmly invite you to participate in the online collaboration platform, which has been set up for sharing experiences, asking questions, and most of all, solving problems regarding Inspire implementation. In the end, a few words about new developments that we are planning for the GeoStatistics portal. Just recently, on Friday, we started the phase 2 project of the GeoStatistics portal, which consists of 3 main stages. First, we want to revise our point-based statistic framework. We have some new functionalities planned for the GeoStatistics portal, and we will be developing new datasets and services that fall in the scope of Inspire. To make it easier to maintain our point-based statistics framework, first of all, we were going to make a software update. We're going to update our ArcGIS from 9.3.1 to 10.3. We're going to implement a system for reference data distribution that is automated. We also want to automate operational data. Those statistical address points and statistical division board boundaries will be distributed and backed up automatically, and also our GIS operators asked for minor improvements in the dedicated application. That's going to be done as well. In the GeoStatistics portal, we're going to implement a module for advanced spatial analysis on microdata. We're going to implement our extensive local data bank in its full scope. We plan to implement a tool for on-the-fly visualization of user-supplied data. We will release a mobile application and some other minor improvements. As you might have guessed, all census results were collected with reference to a single address point. That allows us for spatial analysis in any desired area, hence the advanced spatial analysis module that at first will be available only for users within official statistics to create advanced presentations and make them part of their publications. Maybe further on we will release this module to other authorities. Our huge database with lots of statistical data, which is the local data bank, is going to be implemented in its full scope. Most data in the local data bank are available since 2003. So all of this will be in the GeoStatistics portal in the upcoming months. As I said, we want users that seek statistical data on maps use the GeoStatistics portal as their main tool. So we want users who have their data that are not present in the portal. They have them in a table. They can bring this table to us, map their statistical units to ours, and use our tools for the cooperative maps and diagram maps to present their own data and export them and use as they like. We are developing a mobile application for the 3 major mobile platforms as well, and a few other improvements of our website's content management system, monitoring system to better monitor use of different modules in the portal, and Inspire services. So we will get to know user needs better, and also some tools for us administrators to help the portal behind the scenes. We are upgrading the user management system and implementing a language version manager. The new Inspire services, as you might have guessed, are statistical grids for the statistical units and population grid data that are in the scope of population distribution. And those, since it's new data, have to be provided until October this year. To summarize information about the portal, for now it gives access to a huge amount of data, census results, and the local data bank. We have a variety of cartography presentation methods. We provide Inspire compliant services. And as you heard, we have exciting new developments coming. Aside from the GeoStatistics portal, we also take part in various projects and initiatives throughout Europe. Marie was talking about the European Forum for Geography and Statistics, which we are participating for quite a while now. We are also a part of the GeoStat 2 project that was described by Marie in detail. And we are taking part in Eurostat grants. At the moment, we are calculating spatial statistics and methodologies for statistics on infrastructure, transport, and education. And in the future, we are planning to develop statistical linked open data. That is all. Thank you. I'm open to questions after the session.
Thank you, Miroslaw, for a very comprehensive presentation on an evolution that has taken place since 2009, where there's been a shift from paper maps to not only a point-based statistical database, but now looking at addresses in more detail and the ability of being able to do analytics and visualization at that unit level or at that address level. And in some of the development paradigms, particularly around statistical grids and population census grids as well, available for the public. So thank you for your contribution, and we'll hold off questions until after the presentations. Thank you.
Thank you.
I'd like to now present our next speaker, who is Rina Tammisto. I apologise, Rina, who's a senior statistician in Statistics Finland. Rina has worked as a senior statistician at Statistics Finland since 1999 and has quite a significant experience in spatial statistical data production and development, and has been heavily involved in the implementation of Inspire and tasks relating to the implementation within Statistics Finland and also in the GeoStat projects. She holds a Master's of Science degree in Geography and has many other studies, including graphic design, to her repertoire. I'm a bit envious of that. With the theme and topic, Inspire implementation is a driving force in developing statistical services at Statistics Finland. Rina, you have the floor. Thank you.
Thank you. As you heard, the Inspire implementation has had a huge effect in delivering statistics, and now we are in the phase that we start to make services up on the top of the created framework. My content for this presentation is little about this open data, open statistics policy in Finland, implementation of Inspire at Statistics Finland, and then how we utilize these new data and technology when we are doing services, and what kind of challenges we have faced in this process. I use the term spatial statistics. I'm not sure is it a common use, but here it's used as geospatial data with statistics and or table data with location information. Statistics Finland do a lot of cooperation on many levels, and we have to bear in mind when we are doing solutions, for example for services, that the solution should be sustainable in many levels, so it has to work and it has to be understood in other forums as well as in national level. The open data policy started 2012 because of PSI directive, and the Ministry of Finance in Finland started National Open Data Program, and because of that, Statistics Finland also start to open data. We opened a StatFin database with huge amount of PX files, which cover over 200 statistics. In addition, from spatial statistics point of view, we opened last year road traffic accidents as point-based data, and PAV open data by postal code areas was opened this January, and that consists of 100 variables by postal code areas, and it's updated every year. So the Inspire implementation started also as 2012, and last year we opened VMS, VFS service interfaces, and data was fixed, and we made metadata descriptions. Both the data and the metadata was published in National Geoportal, which is run by and held by Finnish National Land Survey. We also set up a website for our own data for derived downloading. Our experiences from Inspire so far has been that it has really raised the level of understanding and skills among the staff. We have now, so to say, permanent and legal position in the national SDI. We think that publishing spatial statistics in the National Geoportal raised the awareness of them also among the users. And we actually got also a quality award 2014 in-house, and it has had certain effect also in Statistics Finland. Well, I think the most important thing in implementing Inspire has been that we have the service interfaces, and after that, basically all new innovations has been based on those. For example, right after we stopped the Inspire project was stopped, we create a service for municipalities, and we serve the sub-municipal areas by using those interfaces. So when we are now thinking about new services, we use the service interfaces. So we are now, as I said, in the phase that we can utilize these, and when we are utilizing our spatial statistics, we should take a look at the Oskari. Oskari is the base for Finnish national geoportal. It's open source software. It uses open source components, and it's licensed by open source licensing. And Statistics Finland has also took part to create new facilities, new functionalities to national geoportal. We have EU-funded spatial statistics on web project, and in that we have designed some tools for using spatial statistics. We also took part to this Oskari steering group and Oskari network last year, and we have possibility to take part and see what's going on in Oskari now. We will have a GIS review on autumn, and in there we try to figure out how we can utilize this open source Oskari in our house. We have made Oskari installation now and start to pilot that. We will see if Oskari might be the solution for example, create statistical services. After taking part to these forums, we also were invited to take part to Map Services for Decision-Making project. This is a project which was run by the Ministry of Finance and was set by the Ministry of Finance and run by the National Land Survey of Finland. It's part of this kind of ICT program which supports new innovation and so on. The technical solution in this project in mind was Oskari, and how decision makers could use Oskari application so that they can have the functionalities in there that they need. We also use in this project other statistical web application for stimulation use. We train and make web inquiry and interview the test users, and the results was the users would like to easy access to all data, all open data, all statistics. They like to search data by the web application. But on the other hand, they would like to have access to particular data. They want to do some kind of analysis, and they want to repeat that analysis next year. They want to have exactly the same variables and exactly the same classification next time. So they would like some kind of work spaces that they can repeat. They would also like to join open statistics or other statistics with corresponding geospatial data. They have also a lot of own data. They would like to add own data, put it in the map, and compare it with the official statistics. To make it more complicated, they would like to create also statistical indicators of their own. They would like to take, for example, one indicator from the National Institute for Health and Welfare and another from Statistics Finland. And in that way, calculate something of their own and use that for the analysis. We also noticed that, of course, there is a need for, when we are talking about statistics, the map is not enough. There is need for graphics and tables and tools for using tables. And in the end, these decision makers and the analysis doing for those, they need to have reports, they need to have embedded maps, for example, which is now possible in Oskari, but that should include also graphics and tables. And there is still a need for sort of printed maps or PDFs. They need to have fixed map pictures as well. So we saw that this makes a lot of new functionalities that should be in National Geoportal or other Oskari application or other application where statistics are used. There should be this sort of possibilities to select data, tools for visualize and analyze data, and compile a report from all that has done. So all this makes a lot of challenges and requirements for developing services. The functionalities that was mentioned makes statistics that should be somehow intelligent. The data should be found, it should be machine read, it should be compared with other data, other statistical data or other geospatial data, and it should be compared to other versions of the data. So a lot of metadata should be involved. And now we are in the situation that there is not so much or not so harmonized and systemized way how to deliver open statistics for this kind of use. I would say that Inspire type development, sort of very structured way, should be needed there too. Of course, a lot of standardization is done among statistics, but my worry is that this standardization doesn't cover the interoperability with spatial statistics and geospatial data. I hope Inspire is once again a trigger for something new, because the unique identifiers has been is required for Inspire data products, and use of these identifiers brings the external identifiers to also to statistical production. So the idea of these external identifiers should be considered widely as well. There's an example of a JSON.table browser picture where this PX API table is read as JSON.dat, and you can see that it's just a table, but if you need to know something, the metadata is separately served for the use. And my conclusions are that in order to create interoperable services, there should be, with interoperable data and tools, we need to have cooperation. We need to have joint standards in use, both for statistics as well as for the services. And we need joint projects which are beneficial for all participants, so they can see that doing this in my part would support the other part in this way. And we have seen that this merging geospatial data and statistics, it's very hot topic right at the moment, and I just hope that these political ambitions will be concrete advances in the service level. One kind of solution for serving statistics for in this open use could be like this. This is an illustration for in the final report of map services for decision-making project. And here I'm not going through the model, but it's similar like the spatial data infrastructure is structures. There's the data level, there's the service level, and there's the application level. And in that way, we could also think serving statistics. Okay, thank you.
Thank you, Rina. Much appreciated, and a good example there where we've heard a discussion around open data and open sources as well in terms of how we deliver information. And some key points around access to data and what users are wanting, and we see that with people wanting more access to all of the data than just some of the data, particularly in terms of analytics. And some of the challenges in that, particularly when Rina was talking about metadata and the standardization and the issues around statistics versus geospatial information. But a key point that she finished with, which rings very, very true, is that integration requires cooperation, and it requires the supportive structures as well. And we're very, very familiar with that. So Rina, thank you. I would now like to introduce Susanne Schnorr, who's head of unit in the Federal Statistical Office of Germany. Susanne is head of the Coordination Regional Statistics Indicator System, has much experience in this domain. She has a law and economics degree and also a PhD on regional simulations. She's a member of quite a few expert groups, both nationally, regionally and internationally, but in particular, she is the official statistics expert in the European Strategy on Europe 2020 and also the Sustainable Development Goals in the post-2015 process that's happening within the UN system at the moment. So with the topic Inspire, Sustainable Development and Measuring Progress from German official statistics perspective, Susanne, you have the floor. Thank you.
Thank you so much for this kind introduction. Good morning to everybody. I think we should close. Thank you. So now I want to tell you something about Inspire and its importance for sustainable development strategies. It's more in terms of usage. Most of the aspects you've already heard, but I tried to combine them in a quite different way to show you how Inspire could be used for policy making. Now I wanted to go into four parts deeper. First of all, I wanted to tell you something about open government, but I will do it briefly. Then I think sustainable development is what matters most in modern times. And I want to show you how official statistics can contribute to these processes. And finally, I want to draw some conclusions. So first of all, to go back to the aim of Inspire, it is a tool that should assist policy making with direct or indirect impact to environment, and in our times, what is not environment. So in Germany, we established 17 legal acts, one for the federation, 16 for the Länder, and there exist always arrangements at municipal level. So I think the GDI is very well established. Now the major elements of Inspire as I see it. First of all, it's quite clear, it's interoperability, it's about metadata, services, and so on. You've heard about that. Then I think what is more urgent for me, these are the thematical issues. and you have Annex 3 of INSPIRE with 21 thematical issues from land use, about population, demography, human health, and so on, until natural risk zones and so on. Then there are several regional aspects covered by INSPIRE, and I think it's important because it's a tool for regional visualization. There's, first of all, the coordinate reference system, and then there are some rules about addresses and administrative units, which matters to official statistics as well. And then we have regional statistical units that is of most importance for official statistics, such as grid-based data or administrative or non-administrative units. Now, I think INSPIRE should be also a tool in terms of open government. We have already heard about that. There exist also several legal acts at European level, agreements at international, supranational level, such as the OECD, and at national level as well. There is a lot of rules, I think, and for Germany we try to serve the European needs as well as the OECD needs. So Germany has signed also the Open Data Charter of the OECD G8. Here are several GIS for open government in Germany. The one on the left side, GDIDE, it's the application for INSPIRE, and then we have GovData, that's according to OECD's Open Data Charter, and we have another one of the German Eurospace Center about disaster management, and these are 3 standalone tools, I think. Now, what I want to come to the main topic, what does sustainable development mean? Sustainable development nowadays is not only referred to ecological aspects, it's more the interlinkage between ecological, economic, and social development. And it is not only for the current generation, but it's also for future generations. And there's another regional aspect in this definition. It refers to the Brundtland report in a couple of years ago. It holds true for here and now and across the borders, or that means elsewhere. Now, what are the major issues of sustainable development, or it's sometimes called progress measurement? You can do so as you like. First of all, the human being or people are at the center of these policies. So, first of all, I think material conditions matter. It's about income, wealth, housing conditions, including sanitary, energy, and so on. Jobs and earnings are also of importance to gain income or create income. Then another aspect are living conditions. It's a broader spectrum with more or less preconditions also, or the general frame about education and skills, health and safety, or life satisfaction in different areas, or overall life satisfaction. And these are also the drivers, I think, for material conditions. As you can imagine, income is often closely connected to education and skills. Then I think the environmental conditions matter, natural resources, ecosystems, climate, and so on. And there is a 4th pillar. It's the governmental framework, which has to be ensured. That means that the governments have to provide their policies in a transparent manner. Justice has to be guaranteed as well accountability to citizens, the same of, or one point of open data and or open government, and good governance and civic engagement also matter. Now here, this is where the different aspects of sustainable development. Now here are the aims at political level. First and foremost, it's growth and jobs. And I think it's generally agreed. Then we have cohesion, inclusion, integration, participation. That means these aspects refer to vulnerable societal groups or less integrated groups. And then the third aspect are protection of the natural environment and development of renewable sources and so on. So now here a timeline of all the activities at national, European and international level. In Germany we started in 2002 with a sustainability strategy by the German government, and it consists of 21 indicators for the 21st century, but really that are 39 indicators if you have a look at the, or count the breakdowns. So, and this strategy is monitored every 2 years by official statistics. We release a data report, and every 4 years there is a comprehensive public assessment of that. And then it has been decided what are the future major aspects or how to go further, and sometimes some indicators, statistical indicators, have been modified. Then we have the OECD's Better Life initiative. I think everybody knows well or hope, so it's a very comprehensive one, but it is limited to the set of indicators. I like it very much. And then we launched in Germany in April 2015 a new strategy. It's based on citizens' dialogues. These dialogues are organized by associations and the government, or the different departments of the government, and it is also possible to do it online, and the aim is to create an indicator system which can accompany the strategies that have to be developed. Official statistics, I think, has a lot of data. We provide 400 statistics, of which 2/3 are EU-wide harmonized. So these data are also available at European level. We have different publications, releases, always state-of-the-art, including mobile devices, and our major tools here are Genesis Online. These are data bases with 500 million entries. It's above NUTS. I do not want to go further at regional level, at European level. And then we have regional database, and the tools are, or the techniques or the technology is the same, used for both databases, so that it is much easier for the user to look for data in the one database on another one, and they are linked to web map or to maps, as you see on the right, and everything is web map based. It's open source based, and we have a lot of other interactive tools, also maps, and we release also grid-based maps for the censuses in the last census round, for the agricultural census in 2010 and the population census in 2011. Now here are some examples about aspects of in terms of sustainable development, and these here refer to underrepresented societal groups or that are vulnerable to some extent. One aspect might be early school leaving. On the left you see early school leavers, and you see the bold colors, they indicate that there is a high number of early school leavers in the eastern part of Germany. Another aspect is at risk of poverty, and we calculated according to the European standard. And here as well you see that in the eastern part the people at risk of poverty are much higher than in most of the western parts. And if you want to go into deeper analysis, I think then you have to use bar charts or something here presented for German cities as well. Another example, I think it should show the range of the broad spectrum of sustainable development. Here nutrition matters, and here it's shown at a grid-based map the type of farming, and then you see it's spread all over Germany. Then we have participation. It means political participation. Often it is measured by voters turnout, and here it's shown for the last German elections to the parliament. And then to give some idea about future developments, it is the last map on the right side is on internal migration. That shows where German regions will gain population, and these are the dark spots, and where they will lose population. That might cause some problems. So here's third example. It's on the left a complete map, and on the right grid-based maps for the census. And you can zoom in and you see that grid-based maps are absolutely state-of-the-art, and they are effective and stable over time, so that you can use several layers. And yeah, it's I think a very good idea to release grid-based data. Now coming to, I want to complete. I think there exists a lot of geodata infrastructures, at least at the level of the European member states, but I think often they are not interlinked as it could be. So something could be done in this direction. Then I think we all know about the thematic issues of Inspire and the modeling. It was a hard work, I agree, and I think the first steps have been undertaken, but more work has to be done in terms of user needs and in terms of thematic themes. And I think these geodata infrastructures are not only useful at national level, it should be guaranteed that they could be used as far as possible across the borders. And I think a lot of work should be done in that direction. Now, content matters for me much more, I think, because user needs are for official statistics always crucial. And there exists enormous demand of high quality information worldwide. I told you the United Nations Sustainable Development Strategy is under construction, will be finished by September, and will be signed by the heads of the states, and it will be accompanied by a statistical indicator system, and first drafts of the indicators exist, but a lot of work has to be done. And I think what has to be taken into account is also developments which are well known in our days, such as aging society, at least for the European member states, then urbanization. That means that people, that cities will grow, and there must be new interlinkages between urban and rural areas. And I think Inspire should also be a very good tool in terms of new data sources, as it is here discussed. And I think big data is such a big issue, and I hope we will go further in this direction. Thank you.
Thank you, Susanne. Much appreciated. And we got a good overview there of some of the issues around statistics and sustainable development and the policies that are starting to be thought through on some of those processes. Some good comments there around the interlinkages, so not only integration but also interlinkages, and certainly from national to global is going to be very important in the SDG process, and harmonisation of thematic areas of interest and data and themes are going to be is certainly going to be a challenge over the next few years as we start bedding down these sustainable development goals. Thanks very much, Susanne, and I'm sure there may be a couple of questions on that. Finally, I'd like to introduce our last but certainly not least presenter this morning, Sharthi Laldaparsad, who's the Executive Manager from Statistics South Africa. Sharthi is the Executive Manager of Policy Research and Analysis at Statistics South Africa. She was the head of Geography Division for many years. I won't say how many years, Sharthi, but also included project manager of the establishment of the South Africa Dwelling Frame. She's a member of the South Africa Committee for Spatial Information and responsible for the development of South Africa's spatial data infrastructure. With the title Achieving the Vision, Geo-statistical Integration, Addressing South Africa's Development Agenda. Sharthi, thank you.
Yeah. Thank you very much. This is the title of my presentation, Achieving the Vision, Geo-statistical Integration Addressing South Africa's Developmental Agenda. Now, this is a series of presentations that I am doing with this title, and I've now introduced this part of it, which is Geostatistics. So I will keep doing this title for a while until I feel totally satisfied about it. So just bear with me if you see it again maybe next year. I'm still not satisfied with it. So I will talk about Statistics South Africa and the relevance we've placed on geography to an extent in which we want to institutionalize geography through legislative change. I will talk about South Africa's developmental agenda. And here you're actually forced. This is really the impetus. So we don't care if you come from statistics or you come from geography or from environment or agriculture. When the president asks the questions, he doesn't ask you, tell me the statistics and then tell me the geography. So the questions are becoming very integrated from the politicians as well. So that's really the impetus for this tight integration. And then I'll focus on usability, which is actually the key strategic direction for Statistics South Africa through geostatistical analysis. The few examples I want to show you is indicators of growth and development, municipal capital spending patterns, estimating and predicting and classifying, and then I'll have some concluding remarks. So like many statistical organizations, and we've had quite a few presentations this morning. We had the Swedish and the Finnish presentations, which were in the Poland one, very, very good presentation. But we also started in a very naive way with geography at Statistics South Africa. And the main thing was, we don't like these paper maps, they're just so cumbersome, let's just automate it, let's put it in some sort of computer system. So we also started it in that, and who would say that today it would actually become fundamental framework data for statistics. So you can see there we actually go down right from the numerator areas down to the actual dwellings and even businesses in Stats SA. So statistical geography has now become a key strategic direction for Statistics South Africa. So the Statistician General has put it up in bold. This is the strategic direction. And over the years, there are things that have actually stood the test of time. And therefore, we believe in the statistical geography. One is the standard geographic frame and how it must be consistent and stable for statistics to operate. The other one is to actually have a small building block that can roll up to the different geographies, and then having reliable framework data, like the dwelling frame, like the business frame. The other thing we've picked up is we don't work in isolation. And in order for us to keep our statistics updated, we actually need, and our frames updated, we need to work with other people and other suppliers. So we've built strong dependency on South Africa's spatial data infrastructure. And the other thing that's coming in now that's very important, that's building on this strategy, is actually analysis and geostatistical analysis, not just thematic mapping. We started with thematic mapping and visualization, but now our boss wants to know more. The questions are becoming more serious. So this is South Africa's National Development Plan. We've got one. It's called the NDP Vision 2030. And when we started off, we did the diagnostics. And the diagnostics said we have too few jobs, poor education, crumbling infrastructure, which actually summarized to poverty and inequality. And the plan was actually to take us from poverty and inequality to prosperity and equity, where we could have more jobs, quality education, etc. So this is one line of sight, and this is the message from government. You know, everybody must line up their ducks in the same direction, which is actually a very good, clear message from government. And obviously, in a system like this, the evidence base becomes important. Spatial and statistical information becomes very important for our developmental agenda. In a system like this, we also realize that not all data belongs to us, even statistical data. And how do we actually utilize that? So we built a dependency on the National Statistical System. The National Statistical System is part of the Statistics Act. And I've spoken about the South African Spatial Data South African Spatial Data Infrastructure, which has its act on its own. So taking from best case scenarios, I found this of Indonesia, and you can see the trend is location and fact-based policy making. So this is really my new area at Stats SA. I've moved from developing geography in Stats SA, which was very much collection of points and lines and polygons and enumerator areas, to actually how do we actually use this and enhance all the spending that we do. And the issue around policy analysis becomes more important. And obviously, that does incorporate the geographic and the statistics. So I've got a few examples, and I'll show you. The first one is we collect a very simple statistic, and those of you from a statistical organization, you'll know about the building plans approved and the building plans passed. So I've mapped this over the years, and from 2006, 2007, 2020, right up to 2013. And the pattern is the same. It's always the same municipality. This is South Africa with the 9 provinces and the 260 odd municipalities. And you can see over the years, you actually see the same pattern. So it's the same municipalities. So these are the things we present to policymakers and say, the pattern does not change. I mean, these municipalities, they're not attracting. It's just the main few municipalities that are attracting. So how viable and how sustainable these are. So how do you actually incorporate what you see in data that you have distributed in tables over these years? When you look at the picture like this, you see more than half the country is actually gray. And it becomes a concern that we are sort of dysfunctional in the country. The other example I'm going to show you is around municipal capital spending, but the main thing is around infrastructure. We all know the vicious cycle around infrastructure, and South Africa and even Africa will be spending millions and trillions on infrastructure. You can see that infrastructure promotes economic growth. Economic growth funds infrastructure. Infrastructure supports development. Development demands infrastructure. Development leads to economic growth, which stimulates. So this is sort of the vicious cycle and the important role that infrastructure plays in our society. So the example, and we're going to be all over South Africa. So this is the city of Johannesburg. And if you look, this is census 2001, the population proportions for census 2001. And the red and green lines are actually our infrastructure. We put the bus rapid transport system. We call it the rear via bus rapid transport system. And that was done somewhere around 2007. And when you look at 2011, the population proportions for 2011, and this is the question is, really, is there some sort of disjuncture between where we put our infrastructure and where people really are? And how much of statistics go into planning? So this is the end, the 5-year capital spending picture, and you can see where the spending is taking place, where the people are, and where the infrastructure actually goes, and how we should actually make use of and combine all this information to make these policy decisions. But often when we present these things, people always come back and say to us, census 2011 is old. We can't plan because it's old, you know. And therefore now I started looking at things around estimating, how do we actually use the information we have, bottom up, top down estimation, using spatial information as well in estimation. And this is what I've done so far, is on the first map, again we're in Johannesburg, census 2011 population. And then what we have our detailed dwelling unit. And you can see the distribution there. Where the circle is, I wonder if this works. So where the circle is central Johannesburg, where I would say it looks different from the population figure. So one will actually think, oh, okay, maybe there's a lot of empty dwellings there, And the last one is the 2014. So people start getting excited when they see this picture, 2011 dwellings and its distribution, and then the 2014 dwellings, where you can start looking at similarities in terms of where you'd expect population to be. And there's still that case of the central Johannesburg there. So if the vision is taking infrastructure to the people, we've got to be very responsive and be able to use our information to present things so they can actually plan. Since we do censuses every 10 years, 2011, the next one is in 2021. And then, so it's very good to actually look at trends, and this is the capital spending pattern. So you can start complaining where the spending is taking place and where the people actually are. But as statisticians, we always want to be absolutely accurate. So the next step is to actually look at, population itself, knowing that there could be a discrepancy between the dwelling frame and population estimates, which will be the household, the household count, which is your dwelling unit, times the population per household, times the group quarters, and other statistical formulas as well. So predicting and classifying, that's another area in which we looked at, and it's getting more serious now, where we actually say, we want to be held accountable for what we say and not just showing things on maps. We want to really be sure about what we're actually saying, and statisticians are always like that. So I did the urban-rural classifications using spatial statistics, and this was a paper with my co-author from University of Witwatersrand. So I like working with the university professors. They teach me a lot. And the urban-rural is still fundamental for South Africa. It's actually a whole chapter in the National Development Plan, so it's a key priority for us. And then the urban side is under human settlements. So this is about classifying urban and rural using statistical and spatial information, so using socio-demographic information and environmental information. Now, Statistics South Africa, we do define some sort of urban and rural by using administrative boundaries, saying if you're within this boundary, then it is urban. And a lot of it is actually based on visual interpretation, and I'll show you that map as well. So in this case here, we use the census 2011 data, population density, percentage female, the age distribution, schooling, unemployed, income. The literature also talks about in-migration. Urban areas tend to attract a lot. And then use the dwelling frame, percentage residential, percentage commercial, and then using classified satellite imagery, the built-up settlements, roads and rails. They say, those things converges into the urban area, and one would actually see more of that. And then natural water and wetlands, you wouldn't really see it in urban areas, more in rural areas. And then the different methodologies that we use to actually try to have some indication of urban and rural without actually falling back to the administrative definition. Many of you are familiar with linear logistic regression, but obviously if the variable that was modeled was population density, because that was actually what the literature said is a good indication of urban and rural. And using linear logistic regression, the first thing you got to do is dichotomize that. And the question then comes, what is it? Is it 500, 1,000, 1,500? Then principal components, because you have so much of data, you have so many variables, and this won't work in these methodologies. So you need to actually reduce the variation between all these and come up with just an index of maybe 3 or 4. So I took principal components and just took the first 3 principal components into geographically weighted regression. The top picture basically explains geographically weighted regression, where it's based on the first principle of geography, is that everything is related, but closer things are more related, which is a very popular saying that I think was Toblin that actually said that, yeah. And then I found another algorithm, which is the Amoeba algorithm, which is looking at spatial clusters. So spatial, it's actually cluster analysis, but contiguity constrained. So these are very interesting for me, using spatial data and statistical data to do this analysis. So that is StatsSA's definition of urban and rural, sort of proxy of it, where the yellow and the sort of darkish yellow is rural, and this is the province of KwaZulu-Natal. And this area here that is dark here is actually the metro area, the eThekwini metro area. And that's why it's more on the urban side. So what did linear logistic regression give us? And you can see the patterns of, and linear logistic regression, as you know, is a global method where you only have one equation for the whole, it uses all the data and you have one basic equation that, and while geographically weighted regression would give me an equation for every single EA. So you can look at the difference and how contiguity and adjacency actually plays in there. And the last one is amoeba, which I find very interesting, because it's actually now finding homogeneous clusters that have similar characteristics within the province itself. But then it starts getting very, very, you got to analyze it further, and obviously you start looking at your local R-squares and how good the predictability is. And you can see that the model predicts very well in the more rural areas, but does not predict very well when I show you where the metro area is, because the polygons start getting very small and they become more heterogeneous. So even GWR starts becoming unstable when that happens. And then obviously your standardized residuals, you're looking for patterns there and doing an answer. Local models, again, you can see the metro area goes up and gives you warning signs when you actually use that model. Okay, so some concluding remarks is that, and I made the statement also in our UN meeting, is we really want that seamless integration between geography and statistics. And we believe that every statistic must have a geography. Never collect statistics without geography, always carries geography. And that the other thing that we are pushing now is that geography must be collected at the point where the event has occurred. Statisticians are very famous for collecting information and not taking the geography. And we say collect it right at the point in which this has actually occurred, at the unit level, or the respondent level. And we have a national statistical system, and then you have the spatial data infrastructure. Obviously, they are run by two different organizations in StatsSA. But here, this is where you have to break down the politics, and you have to think about what's good for our country. And I'm proposing national geostatistical system instead of a national statistical system. I'll probably get fired when my boss sees this presentation. And really focus on usability, because that's the way people are actually going to see how you can combine the spatial and the statistics, and how it actually, you can tell stories going deeper into the statistics, going and explaining things in a more detailed way for the evidence base. Thank you.
Thank you, Sharthi, much appreciated. And yes, the discussion on geostatistics will continue for a while, I think. And it's one that I've been using as well. We saw a very good presentation there on some of the issues and challenges, particularly when we think about, I guess, something that's not always thought through is some of the perspectives that come from African countries as well, and what we need to do in terms of integration and how we go about that. What I liked in that presentation was discussions around how we think about these classifications, and also location and fact-based decision-making in policy and where that fits. And the idea that we need to think more about geography, and it's very heartening to hear Sharthi talk about at the end there around statistics must carry a geography, and that's certainly a challenge that we have globally for the 2020 round of population censuses. So thank you very much. Now I will concede that as a moderator I have failed, because we have run out of time. And unfortunately, the reality is I didn't want to stop those presentations either, but what I would like you to do, if you get the time, is to meet up with the presenters, or if you have any questions, do go to them and ask them any particular questions you have. Unfortunately, and I know that we're on a tight schedule, we can't take any questions at this time, so I apologise for that. But if you could, in conclusion, if you could just, with me, appreciate the contribution from our 5 presenters today, and I hope you learnt a lot and got some benefit out of their most valuable and expertise presentation. So thank you for all 5 presenters. Thank you.